this down. Holy moly, look at that. Yeah. Hey, what's up guys, John Stayskull here. So you may have come across videos or systems before that have enemy patrol AI that simply moves left and right between two fixed points based on a distance. But that's a problem, because if you have walls or a crevasse, like a hole, then the enemy doesn't know what to do. So in this video, I want to show you guys how to get around those things and build an adaptive enemy patrol AI system from scratch. All right, let's get into it. So I've just set up this little sample scene here that we're going to be working from. And this sample scene, I'll make it available for you guys down below in the description of the video, so you can follow along with me if you like. So you can see here, I've just got a simple enemy, which has a box collider and a rigid body component with the standard settings. And I've also got just a terrain holder, which is holding a bunch of different prefabs for the ground tiles. Nothing particularly exciting, and those ground tiles have like box collider 2D, just for convenience, so we can later create like walls and stuff around the player. So the first thing we'll want to do is get this enemy to move. So we'll do that by selecting the enemy, clicking add new script, enemy script, create and add. Yep, and then we'll double click that to open it in Visual Studio. First thing I want to do is just to create a rigid body 2D reference, RB2D, and we'll also create a float called move speed, and we'll just make it 5. We can play with that later. And in the start function, we'll say RB2D equals get component rigid body 2D, and we'll want to just apply velocity to that rigid body, and we'll create a fixed update for that, because you guys might know that anything physics related should be done in the fixed update. Rigid body 2D dot velocity equals new vector 2, and for the x parameter we'll pass in the move speed. So we'll be giving it 5 velocity on the horizontal and 0. Actually, what we'll do for the y, we'll just say rigid body 2D dot velocity dot y. This means that we'll just continue applying whatever's already set as the y velocity to the object. All right, so that should theoretically be enough to move this guy. Oh, he's moving. Whoa, what's that? He got stuck. Yeah, okay. So you guys might be familiar with this issue. Anytime you have game objects that have like tile-based box colliders, it can cause, like, you can get stuck on the little edges. You can resolve this in a few different ways. You can go into like the physics and collision settings and change how sensitive it is. But we'll just make this quick, and we'll just say circle collider 2D, and I'll just make that really small. Okay, so you can see what I've done here. Just going to offset the Y a little bit. I just want the circle collider to kind of catch the edges. It's a bit of a dirty hack, but just for the sake of this tutorial, so we don't get slowed down, it's fine. All right, that fixed it, and you can see the character is moving all the way across the screen. Ship it. Just kidding, we have a bit more to do. Oh, what I will do quickly, I'll show you the problem, right? So if I create a wall here now, well, we know what's going to happen. The player's just going to hit the wall and that's it, because there's no logic to tell the player to do any differently. So we want to write that in. We want to give the player a way to be able to see the walls and the floor. And we'll do that by shooting a little linecast or a raycast, but in this case a linecast should be enough, out of the eyes, or not necessarily out of the eyes, but forward from the player's position to look for a wall. And we'll also shoot one down to look for a crevasse. But we'll start with the wall, as that's the more obvious one. So to do that, we need a few things. First of all, we need a new layer. Go to Edit Layers, and under the Layers drop down, let's create one called terrain, and we'll be using this for both the wall and floor, which is essentially the same in this case. And we just want to go into our prefabs for the terrain. You can just select it from here, and just want to give that, yep, you just want to assign that to the terrain layer if it's not already assigned. And now, just with our enemy selected, right click, create empty to create an empty child, and we just want to create something called a cast pos, or cast position for short. And this is where we're going to be shooting the ray or the beam from. And you want to just give it a little gizmo here. If you click this little box, and that will create a little visible gizmo so we can see it. And instead of positioning at the eye level to look forward, because we won't want to reuse the same gizmo for shooting down, I'm just going to put it here a little bit, slightly to the front of the player, so we can kind of shoot that way and also shoot downwards looking for a hole. So back to Visual Studio at this point, we'll just need to define a few more things. We'll say game object cast pos. You know what, we'll make this a transform, because all we need is the position. We don't need the whole game object. And you might know that the transform is a kind of like a subcomponent of the game object. So it's a bit more lightweight when you don't need the full game object. And we'll serialize field, because we'll drag that in through the inspector. And we'll also want to create a float, and we'll call this one base cast dist. Base cast distance, and we'll serialize that too. And this will be the distance in which the player can see, the sensitivity for how far he can see. Oh yeah, we're going to be also turning the player left and right. So we just want to create a constants for the strings, so we're not writing left and right in quotes every time. It's kind of good practice. So const string left is the convention, equals left, and we'll make a new one, const string right equals right. So again, this just stops us from creating typos and having to have to write this kind of stuff over and over. Just gives us a reference through these here. And we'll also need to store the facing direction of the player, and we'll do that as a string. We'll call it facing direction. And this should be the default for which way your graphics are facing. In my case, it's right. So facing direction equals right. You can see now I can use those constants that are set up here. Very efficient. Oh, one other thing we'll do, because we're going to be turning the player around, I might just store the scale, the base scale rather. So I'll say base scale. So base scale equals transform dot local scale. And just a quick comment, if you're not getting your autocomplete like I am right now, just make sure that your Unity is linked to Visual Studio through the Unity preferences. I know some people are at comments in the video saying, hey, my autocomplete isn't working. Get that working, it's very important. So this is where the magic happens now. We're going to create a new function here called is hitting wall. And we just wanted to return a bool. So instead of writing void, I put a bool there instead. So the way I like to do it is to just declare the value up the top, val equals false by default. And at the bottom, we just want to return val. Okay, so that's how it's going to work. And our logic will go, our hit wall logic will go in here. So I'll just block in a few things. Float cast dist equals base cast dist. We're going to be working with this locally in this function. And I'll say if facing direction equals left, then make the cast dist equals minus the base cast dist, because we want to shoot. So if the character is facing left, shoot the ray left. If the character is facing right, well, that will be by default here, and we don't have to write it. Alternatively, you could, like, you know, write an else, you know, and kind of repeat the same thing as you have here. But, you know, it's a little bit redundant because we've already got the default up there. But however you like it, you know. All right, so now we're going to want to define our target distance for the ray. So I'll just say vector3. I'll say target pos, and I'll just declare it as assign it the value cast pos dot position. And what we want to do now, we just want to say target. We just want to modify the x value of this target pos. So we'll say target pos dot x plus equals cast dist. You see, so we're plugging in the value that we've defined here, and that'll be either a negative value or a positive value. I might just put a quick comment here for you guys. Define the cast distance for left and right. Oh. Determine the target destination based on the cast distance. Okay, so now we're officially going to draw the ray and look for the wall. So say if physics 2D dot linecast, and you can see here the first value is the start position and end position. You see, so these suddenly make a little bit more sense. And the start position will be this position here. So we're going to say cast pos dot position, and for the end pos, well, we have our target pos right here. So we're just going to say target pos. So for the third parameter, you can see it's looking for a layer mask. So we'll say 1 dash dash layer mask dot name to layer, open and close a bracket, and we're just going to pass in the name of that ground layer we created, which is terrain. And we'll put one more closing bracket there, then open and close these fun things. Oh, looks like I'm missing a bracket there. All right. So if you're new to Unity, this may look a bit like, what the hell is that? Oh my God. But if you've been using Unity for some time, you'll know this is pretty standard. This is a C# convention known as a bitwise operation, and it's using it to find a layer mask. So it basically means we'll shoot a ray from this position to this position and see if it intersects this layer. Unity probably should have hidden this. I think this is a bit kind of dramatic for the eyes to be looking at. It's always going to be 1. Don't try to change this to 2 or anything. It won't work. And this will return true. So it means, yes, we have found a wall. We've hit the wall. Give us a true. Else val equals false. All right, and then we're returning this value. So this whole function is just a bit of just as a bit of internal logic, which then passes back to us somewhere else. And we're going to be doing that from the fixed update function. So say if is hitting wall, like that. And we just want to print or debug log hit wall, just to make sure that's working. And we'll need a wall now. So I'll just duplicate one of these guys here. We'll keep our eye on the... Oh, wait a second. We have not assigned that cast position thing. So on the enemy, script, you'll notice our cast position is empty. So we want to grab that and just drag it in here, or click that little knob there and find it in the scene that way. And we also haven't done anything with our base cast position, and I might just set that to maybe like a 0.2, and we'll run that again. Boom! Look at that. Look at our console hit wall. Yes! Success! Alright, so let's elaborate on that a little more now and kind of flesh it out a bit. So that's cool, we've hit the wall, but now we want to turn the player around. So let's create a new function called change facing direction. And we can even take a string and say new direction. So we can actually tell this function specifically which way the player should move. So, sorry, I should put a void there. Can get rid of that now. So we'll say if facing direction equals left, then change facing direction right. Makes sense. And else change facing direction left. I might just write this out for you guys over here just to make it clear what I'm doing. So if we're facing left, change right. Else if we're facing right, then change facing direction left. That makes sense, yeah? Alright, so now we'll just want to change the facing direction of the player using that new direction argument that's coming through. So I'll just start by defining a scale that we can muck around with and modify. So we'll say new scale equals base scale, because we don't want to modify the base scale. So I'm just creating a new version of that we can tweak. We'll say if new direction equals left, then new scale dot x equals minus base scale dot x. Oops, holy crap, what was that? Okay. Yeah, I think that makes sense. And then else, we must be facing right. But I will write it again for you guys. Normally I just do an else, but I want you guys to clearly understand what I'm doing here. So I'm just going to make it a bit more verbose. So if we're facing left, make our new scale x dot minus the base scale x. Otherwise, make it like this. And now we just want to map that new scale to the object itself. So I'm going to say transform dot local scale equals new scale. Perfect. And we also just want to update the current facing direction. Well, facing direction equals new direction. So we're just mapping our class member that we've got up the top just to this one that's coming through to keep it updated. So we'll have to address this. This code here, which is move the, it's got a fixed value here. So we just want to replace that based on the direction we are facing. So what I'll do, I might just make a float, call it Vx, velocity x. And I'll say move speed. So we just give it a default value. And we'll say if is, what is it? Facing direction, oh my god. If facing, where is it? Yeah, facing direction equals left, then Vx equals minus move speed. And instead of giving the move speed, we're just going to put this Vx. So the move speed is the class member and that we've got up here. And we're just creating another local version of that within the function, changing it to negative or positive based on left and right direction, and then putting that as the velocity. And that sounds pretty good to me. So one thing you also may have noticed is that you can't see the raycast. It's invisible. So what's a good thing to do when making your game is draw the line so you can visually see it. Now this is a very powerful way to keep track of what's going on in your scene, and we'll do that now. It's very good practice. So down here, just above where we're doing that check, I'm just going to use the debug API, debug.drawLine, and we're just going to mimic, see, start line, end line, and we're just going to mimic what we're doing here. So we have our start pause, end pause. Cool. And now we need to give it a color, which is pretty cool. And so we'll say color dot, what should we make it? Maybe like a blue? Yeah. All right, so that should work. And what we can do, we can just maybe increase our cast distance. Maybe we'll say like 0.5. And you might want to tweak that gizmo size so it doesn't get in the way of the actual line. You can do that through this gizmos tab here. All right, so I might maybe just move that wall over a bit here, and I'll put another wall over here because I've got a feeling this could be working. If this works, I'm gonna be pretty damn excited. So press start. Oh, okay. I just paused it quickly. You see the line now? How we can see the debug line? Very cool. So now you can see what's going on. Now the moment that line hits the wall, it should turn the player to the left. If it does, it's going to be a beautiful thing. Here we go. Boom! Ah! Yes! All right. Now check this out. Whoop, whoop. How awesome is that? So you can see now the power of this. You can have any different terrain combination, and you don't always have to be hard coding in values saying only walk 5 units or only walk 3 units. Now you can have a completely organic terrain that automatically has all the enemy AI adjust to it. So I'm actually using this same system in my own game Blood and Mead here, and you can see this patrolling enemy has that same linecast that's looking for the walls. And he's also using that linecast to look for the player. Yeah, so this is my game Blood and Mead. If you guys want to support my work, I'll put a link to the wishlist down below. You see this snake is also using this Raycast to look for the walls. Alright, very cool. So how about the crevasse? Or the holes rather. So let's shoot a beam downwards and counter for those as well. So what we'll do, we'll grab that is hitting wall function and we'll just duplicate this because we're going to make a variation of this. So instead of is hitting wall, we'll say is near edge. So it's going to be a little bit different, which is why I made a duplicate of it. Let's tidy this up a bit. So by default, I'm going to make this true. And here, instead of shooting to the right, we're going to change the Y value because we want to shoot down. So I'll say minus cast S. So this will shoot it downwards. And this time we might make it red. So this one's going to be a little bit different because we are looking for a hole, where with the wall we were looking for a solid object. So now we're looking down and we're expecting to have the floor bit below us. It's only when we find that the wall isn't there, that's when we flag it. So it's going to be it's going to be the opposite of how we did the wall. So this will be false and this will be true. Now, if you're savvy with your code, you could certainly wrap this up into one big function which caters for both the forward and shooting downwards, but because this is largely a beginner's channel, I don't want to tie you guys up in knots, so we'll do it like this. Alright, so now we're going to process this is near edge business. very simply, we'll go up to this condition here. So say if is hitting wall or is near edge, then turn left or right. All right. Good. Ah. Ah, yes, I see the problem. We don't need this left or right cast distance business. This was only relevant when we were shooting the beam forward or back on a horizontal axis. Because we are simply shooting it downwards on a vertical axis, we don't need any of this. So what we're going to do, we're just going to get rid of that. And we're just going to say, yeah, like that. That should do it. Good. Move this down. Holy moly, look at that. Yeah. Absolutely fantastic. So there we have it, guys. Adaptive enemy patrolling. So I hope you guys have enjoyed this video. I clearly enjoyed making it. Give it a big thumbs up if you have, and don't forget to sub if you haven't already. And a big shout out and thank you to my Patreon supporters, both current and past. I know times are tough for a lot of people in the world, and I want to thank you for showing support to this small channel and valuing online education being done properly. There's a lot of clickbait out there, and I try to approach it from a authentic education first direction. So for those of you who recognize that and value that, I appreciate you too. Thanks everyone, see you in the next video, and as always, all the best on your game dev adventures.